All right, so the next thing we're going to look at is solving a matrix equation of the form AX is equal to B. So AX is equal to B is a matrix equation. So A, X, and B are matrices, and the elements of the matrix X are unknown. So we're trying to solve a matrix equation. The matrix equation is of the form AX is equal to B. A, X, and B are matrices, and the elements of the matrix X are unknown. Now, solving the equation in a situation like this means to determine the elements of matrix X. So what is the principle? These are the two principles that allows us to come up with a solution. Now, A, the product of a matrix and its inverse is the I matrix. So the product of a matrix and its inverse is the I matrix. So that means if I multiply the matrix A by A inverse, I'm going to get the I matrix. The second thing that is important to the solution is that the product of a matrix X and the I matrix is X. So multiplying by the I matrix is multiplying the matrix X by the I matrix is the equivalent of multiplying an integer by the number 1. So if I multiply X by I, I'm going to get back X. It is unchanged. So this is our scenario. We have AX is equal to B. A, X, and B are matrices. And the elements of the matrix X are unknown. And my objective is to determine the elements of the matrix X. Now, the first thing I would do is I would multiply both sides of the equation by A inverse. So A inverse times AX is equal to A inverse times B. So what I did there is multiply both sides of the equation by the matrix A inverse. Now, when I multiply A by A inverse, I'm going to get the I matrix. So now I have IX is equal to A inverse B. But remember, whenever you multiply I by X, you're going to get back X. So this is saying X is equal to A inverse times B. Now, this occurs every single time you do it. So what we do is that since we know that these two things are going to happen, what we do is sort of like just jump from the top step and jump to this step. That's this step here. So in other words, to solve a matrix equation of the form AX is equal to B, I simply write back X on the left-hand side of the equation and multiply the right-hand side of the matrix equation by A inverse. Again, if I have a matrix equation of the form AX is equal to B, A, X, and B are matrices, and the elements of the matrix X are unknown. To solve, this is what I simply do. I simply write back the matrix X on the left-hand side and multiply the matrix B on the right-hand side by A inverse. All right, so let's get a chance to see this in action. Example 10. Example 10 says, given that 2x plus 3y is equal to 8 and 4x plus y is equal to 6, we are to A, express the pair of equations in the form AX is equal to B. So what we're really technically going to do here is that we are going to solve a pair of simultaneous equations using a matrices method. And the first thing we're asked to do is to express the pair of equations in the form AX is equal to B. In other words, we must move from simultaneous equation to a matrix equation. So A is going to be sort of like your coefficient matrix. I'm simply going to take the coefficients of X and Y. So this is 2 and 3, 4 and 1. So this is the matrix A, and the matrix A is like my coefficient matrix. Then I'm going to have X, Y. So this is like my matrix X, and this is equal to 8, 6, and 8, 6 is sort of like my matrix B. So what I've just done is I've just written my simultaneous equation as a matrix equation. So now my simultaneous equation is now a matrix equation of the form AX is equal to B. A is the coefficient matrix. I simply take the coefficients of X and Y to form A. B is the column matrix XY, sorry, X is the column matrix XY, and B is the column matrix 8, 6. B says, hence, solve simultaneously for X and Y. In other words, we're going to solve the matrix equation to determine the elements of the matrix X, and the elements of matrix X are X and Y. So my objective is to determine X and Y. Guys, remember, to solve a matrix equation of the form AX is equal to B, we simply write back the matrix X on the left-hand side and multiply the matrix B on the right-hand side by A inverse. So to solve this, the first thing I need to do, I need to find A inverse. Now A inverse is equal to 1 over the determinant of A times adjoint A. Now the determinant of A is 2 times 1, that's 2 times 1, the product of the leading diagonal elements, minus 4 times 3, or 3 times 4, which is the product of the lagging diagonal elements. So this is 2 minus 12. The determinant of A is minus 10. And so A inverse is equal to 1 over minus 10, that's 1 over the determinant, times adjoint A. Now to get adjoint A, this is what I'm going to do. I'm going to switch around the leading diagonal elements. I'm going to switch around the 1 and the 2. So 1 goes here, 2 goes here. The 3 and the 4 stay where they are, but their signs change to minus 3 and minus 4. So this is like the matrix A inverse. Remember, I'm trying to determine what is X and Y, and X and Y are the elements of the matrix X. So I'm going to turn the page in a second. All right, so remember now, we're solving the matrix equation. So we're gonna write back now, remember to say to solve, we're gonna write back the matrix X on the left-hand side. So this is X, Y, that's the matrix X. And we're gonna multiply the right-hand side by A inverse. So A inverse is 1 over minus 10 1 minus 3 minus 4, 2. That's A inverse multiplied by B, which is, I think, 8, 6. So how do we solve a matrix equation of the form? How do we solve a matrix equation of the form AX is equal to B? We write back X and multiply the right-hand side by A inverse. So this is A inverse times B. So let's solve 1 over minus 10. All right. Then now let's multiply the matrices. We're going to multiply the one row by the column. So it's minus 1 times 8 is 8. And minus 3 times 6 is minus 18. So I just multiply the top row by the right column, the column. Now I'm going to multiply the bottom row, 1, 2, by the same column. So minus 4 times 8 is minus 32. And 2 times 6 is 12. So what I have now is 1 over minus 10. 8 minus 18 is minus 10. And minus 32 plus 12 is minus 20. So now multiplying by 1 over minus 10 is the same as saying divide by minus 10. So this is minus 10 divide by minus 10. And this is minus 20 divide by minus 10. So therefore, the matrix, the X matrix, which is X with elements X, Y, would be equal to minus 10 divided by minus 10 is positive 1. And minus 20 divided by minus 10 is positive 2. So what this is saying to me is that X is equal to 1 and Y is equal to 2. X is equal to 1 and Y is equal to 2 are the solutions of the simultaneous equation. All right, so example 11 says, find the inverse of the matrix P. All right, so P inverse is equal to 1 over the determinant of P times adjoint P. So the determinant of P is 2 times 3. So it's 2 times 3 minus 1 times minus 1. So this is 6 plus 1, which is 7. The determinant of P is 7. So P inverse would be equal to 1 over 7 times adjoint P. So to get adjoint P, we're going to switch around the 2 and the 3. So 3 goes up here, 2 goes down here. The 1 and the minus 1 stay where they are, but their signs change. So positive 1 becomes minus 1 and negative 1 becomes positive 1. This is P inverse. All right, so let's carry it as far as it can go. So P inverse would be equal to 3 over 7 minus 1 over 7, 1 over 7, and 2 over 7. So this is utilizing the fact that multiplying by 1/7 is the same as saying divide by 7. So this is P inverse. All right, this says M here, but it should have said P. This says calculate the value of X for which P times the column matrix XY is equal to 3 minus 5. So P, which is, or I should say P now times the matrix X is equal to the matrix B. P is the matrix 2, 3, minus 1. It's not 2, 3, it's 2, 1. 2, 1, minus 1, 3. This is P times the matrix X, which is the column matrix with elements X, Y. And this is equal to B, the column matrix with elements 3 minus 5. So right now you're being asked to solve a matrix equation of the form Px is equal to B. So this is solved the same way as Ax is equal to B. You're going to write back X and then multiply the right-hand side by P inverse. All right. So we're going to use this version of P inverse, 1/7, 3 minus 1, 1, 2. We're going to use that version of P inverse. So X, we're going to write back X, which is XY, is equal to P inverse 1/7, 3 minus 1, 1, 2, times B, which is 3 minus 5. All right, so let's multiply the two matrices. So I put back the fraction 1/7, multiply the two matrices. First element in the row times the first element in the column. So that is 3 times 3, which is 9. Second element in the row times the second element in the column, minus 1 times minus 5 is positive 5. So next we're going to move to the bottom row. First element in the row 1 times the first element in the column 3. 1 times 3 is 3. Second element in the row 2 times the second element in the column minus 5. This is minus 10. So what we have here is 1/7 times the column matrix 14 minus 7. Now multiplying by 1/7 is the same as saying divide by 7. So this is 14 divide by 7 minus 7 divide by 7. So what we have is that the matrix XY is equal to 2 minus 1. Therefore, X is equal to 2 and Y is equal to minus 1. All right, so the final example is example 12. And example 12 says, given the linear equations 2x plus 5y is equal to minus 4 and 3 plus 6 is equal to minus 3, we're to write the equations in the form Ax is equal to B, where A, B, and X are matrices. So everybody should remember that A would be the coefficient matrix, 2, 5, 3, 6. And X is the column matrix with elements X, Y, and this is equal to B, which is -4, -3. All right, so that's what we have so far. Next, we're asked to calculate the determinant of matrix A. Now, the determinant of A would be equal to 2 times 6 minus 5 times 3. So this is 12 minus 15. The determinant of A is -3. Next, we're asked to show that A inverse is equal to -2, 5/3, 1, -2/3. Now, A inverse is equal to 1 over the determinant of A times adjoint A. So this is 1 over -3 times adjoint A. Now adjoint A, I'm going to switch around the leading diagonal elements. So the 6 and the 2 change position. The 5 and the 3 stay where they are, but their signs change to -5 and -3. So therefore, A inverse is equal to 1 over -3. All right, let's go further. Multiplying by 1 over -3 is the same as saying divide by -3. So this is 6 over -3, 5 over -3, -3 over -3, and 2 over -3. So therefore, A inverse is equal to -2. It should be over -2. A positive divided by a negative is a negative. So this is minus, oh, this was -5. Okay. So a negative divided by a negative is a positive. So this is +5/3. And -3 divided by -3 is +1. And 2 divided by -3 is -2/3. So we're asked to show that A inverse is equal to that, and we nailed it. All right. All right, so let's just turn the page and finish up the question. So next we're asked to use A inverse to solve for X and Y. Remember, once we have a matrix equation of this form, AX is equal to B, X would be equal to A inverse times B. So A inverse, using this version of it, 1 over -3. This is 6 -5 -3, 2 times B, which is the column matrix, -4 -3. So we're going to multiply rows by columns. Six times -4 is -24. -4 is 5 times -3 is +15. -3 times Minus 3 times minus 4 is positive 12. So we're at now the bottom row. Minus 3 times minus 4 is 12, and 2 times minus 3 is minus 6. So this becomes 1 over minus 3. This is minus 9. 24 minus 15 is minus 9. And 12 minus 6 is 6. Now, multiplying by 1 over minus 3 is the same as saying divide by minus 3. So this is minus 9 divide by minus 3, and 6 divide by minus 3. This is x, y, and this is equal to 3, and then minus 2. Therefore, x is equal to 3, and y is equal to minus 2. X is equal to 3, and y is equal to minus 2.